everybody. Welcome to this session on building apps for the Lakehouse with Databricks SQL. I'm Adriana. I'm a product manager at Databricks, and this is Chris.
Yeah, I'm Chris, engineer at Databricks.
Right. So in this session, we hope to give you the knowledge to go home and then start building your own apps on the Databricks SQL on the Lakehouse. We will focus quite a lot on building apps using REST API, which we have most recently introduced in our portfolio. But we will also give you an overview of other options that we have in Databricks so that you can actually build apps on the Databricks SQL. If you're here, most likely you know that Databricks SQL is a serverless data warehouse, which allows you to analyze all your data using standard SQL. What is also important for us with the Databricks SQL is that we make it possible to run SQL with your tool of choice. Now, of course, since this is a data warehouse, it's very clear, probably to everybody, that BI tools will be one of the major consumers of the Lakehouse. So in that sense, what you see here on the slide is some of the most popular BI applications like Power BI, Looker, Tableau. We have a way to seamlessly integrate with these tools such that data analysts are able to use their favorite tools, the most popular tools to get insights from their data. We also have tools for data engineers such as dbt and Fivetran, which seamlessly integrate with Databricks SQL so that as well on their end, they are able to use their favorite tools to sort of ingest data from cloud storage and from other systems like Salesforce, Google Analytics, and so on. So in a way, we have a solution to cover the BI workloads. But what we heard from our customers is that there is another category of users. There are other stakeholders interested in tapping into the Lakehouse, so in the data that our customers already manage. So there is a need to provide a solution for stakeholders other than data analysts to use this data. And a few examples include enterprise architects. We heard from our customers that they are keen to integrate the Lakehouse with applications such as SaaS applications, CRMs, e-commerce solutions, data applications that our customers have built already in-house, so that business users, again, other maybe than the data analysts, are able to leverage the insights from the Lakehouse, but while using these tools, so not changing their way of working, not changing the way they've been working since a very long time. We also heard about application developers who are interested in integrating, using the simplicity of SQL with data applications that they would like to build using languages and tools that they already know. So in the spirit of making it possible for you to leverage the data that you already have in the Lakehouse using your tools of choice, we've been investing quite a lot in building a connectivity ecosystem for Databricks SQL. And in that sense, of course, we continue to invest in connectivity with the BI tools, the most popular BI tools out there. So you see here on the upper side of the diagram, other tools than what I mentioned before. So there is also Hex, Mode, and so on. So we continuously invest in integrations with the BI tools. But at the same time, we are investing in connectivity options, or more foundational connectivity options, and that's the lower side of this diagram. You see here ODBC and JDBC. I guess everybody's familiar with these drivers. They've been around for quite some time. And obviously, they are an option to create apps on the Lakehouse if, for example, your runtime is Java, or if you're looking to integrate from a language that implements the ODBC API. So that is C, C++, C#, Visual Basic. So you can definitely use these connectors to build an app on the Lakehouse. But what we've heard from our customers is that sometimes it is more cumbersome to wrap these connectors if you're not exactly looking to integrate from Java or C. So because of that, we started to add connectivity from the most popular languages out there. So here you have Python, Node, and Go. So these are first-party connectors that we have in our portfolio. They implement the database API specifications from these languages. So if we now take, for example, Python, it implements the database API specification for Python, which is PEP 249. So with these connectors, you get out of the box things like managing connections, managing cursors, data type transformation, so there is a lot of logic already handled. Of course, there are more languages out there that we could ever build connectors for, and this is where we added a REST API to our portfolio, and this is what we will largely focus on today to show you how to use a REST API to build apps on the Lakehouse. So I'll dive deeper into what is this API all about, how you can use it in the next part of the presentation. The API is called SQL Statement Execution API. And just like all of the other connectivity options you can use to access and manage data by executing SQL that is sent over HTTP to a Databricks SQL warehouse. And then also over HTTP, you get the data back to your data application so that you use it for basically getting insights from the Lakehouse. Since there is an HTTP framework out there for most of the languages out there, you can use it to build data applications in your favorite languages. JavaScript, PHP, Python, you name it. If we take now JavaScript as an example, I guess everybody who's been active in this field knows about Fetch API. You can simply use it to construct a request, then you get back a response, you handle the response, kind of parse the data, show it in the application, in a front end, for example. There are similar constructs in many other languages out there, so this is where the API can help you really build data applications in different languages that you might be interested in integrating with. But of course, our customers have more complex ecosystems. What we heard is that they would like to integrate from a wide range of applications, technologies, frameworks, and this is where HTTP, being a common denominator across all of these technologies, presents an opportunity. You can actually use the API to, for example, create a sort of generic integration layer across various services that you might have in your ecosystem. So for example, by wrapping the API, which we will see in just a second, you can create more special purpose APIs that tackle the use cases you might have internally to sort of build a middleware that serves the microservices you might have already implemented. Of course, sometimes having a client library is just much more convenient, and this is where, again, by using the API, so like this generic integration layer, you could also create your own client library in other languages where we might not yet have a connector if that's a desire of yours. So that's just to give you an overview of the options that you have, but let's get to know a bit more about the API itself and how you can use it. So to use the API to build data apps, you need to work with only 3 HTTP endpoints. The main one is the one on top of the screen. So that's a post endpoint that you can use to submit any SQL statement to be executed on a SQL warehouse. So it's not just selects, you can submit deletes, you can submit inserts, and so on. As a response to this request, you get the statement ID, which you can use afterwards with the get to either poll for status or get back the results, and then show it, for example, in the front end of an application. And then obviously we also have the ability to cancel requests that were already sent. Sometimes that becomes useful as well. So by using only these 3 endpoints, you can implement a wide range of applications which largely follow this pattern, where an end user types in some criteria, perhaps in a user interface. Behind the scenes, there is a SQL query that gets constructed. It's sent over for execution, and then you get back the data. You show it in the user interface for a user to then consume the insights that are part of this data set. By using this API, we did various sample applications, and one of them, you might have seen it already, is in integration with Google Spreadsheet, with the Google Spreadsheets app. So let's imagine this scenario where we have a business user who wants to get information on orders every day. They are used to working with spreadsheets. They don't know about SQL. They might not want to go into Power BI. There is an option to simply integrate with Google Spreadsheets, and here we have just a few requests that were sort of built in as a menu in Google Spreadsheets. So let's say I want to pull all of the historical orders. I can do so, and now you've seen we already got the data populated. As a business user, I could now use this data to sort of create charts using the familiar interface of Google Spreadsheets. Of course, one can also expand further to this. Let's say I want to get the data only between certain periods. Let's say, OK, so from the beginning to the end of 2022, it's the click of a button. Behind the scenes, I have a query. Again, constructed, I get the data, I can work with it. And just to give you the sense of what happened behind the scenes, as the user was typing this sort of parameters, there was a query constructed, which is still loading. All right. Something is happening maybe with the internet. I hope not. All right. Maybe we can come back at the end, and I can show you the query live. So I really hope now that we don't have problems with the internet. I'll just quickly move on. Of course, I was saying we have 3 endpoints in the API. There is a bit more complexity to it. There are a few parameters that you can use to tune your requests in such a way that you achieve various execution modes. So we talk about 3 modes of the API, synchronous, asynchronous, and hybrid, that you can steer by using this wait timeout parameters. So if I say that after 15, so what I'm saying here is that after 15 seconds, I want the execution to continue in an asynchronous fashion. If I get the results earlier, then I work with it. I can also configure the wait timeout to 0, and then my execution will be implicitly asynchronous. Or I could also configure a certain wait timeout and then configure the request to cancel if that wait timeout elapses. This can become useful if you have queries with very well-known latency, and you know that if the latency has exceeded, then something went wrong, and it's maybe more convenient to cancel the query and then re-execute rather than wait. So I've sort of experienced when talking about the API that it's easier to get a sense of how things work if you see things in action. So here we are going to use Postman just to walk you through all of these execution modes. We have here already everything wired together in Postman. So we have the post endpoint, and we are submitting a simple statement. It's going to return 10 rows on a serverless warehouse. And we are saying, OK, if this takes longer than 10 seconds, continue the execution asynchronously. We are also retrieving now the results in line. And you'll see in a second what are the other options. But by saying that I'm retrieving the results in line, I'll get them as part of the response, so as part of the payload of the request. So I'm submitting this. I think we really have something with the internet. All right. I'll kind of dry run this because we also have the other request. So the other option was to sort of execute the query asynchronously, and we have it here as well. Of course, it's a bit hard to show it in action since we have some issues with connectivity. I'll quickly jump over to this mode. It's called external links.
No, we're testing on a staging environment, so the VPN's not working. Yeah, it's not connecting anything.
But then laptops, Wi-Fi.
Yeah, so it's just the VPN.
I don't know what's going on.
That's why we've got videos of some of them.
All right. We were actually joking before that we really like live demos. So we have some backups, not for Postman. But yeah, it seems like we were actually affected by this curse of demoing live. Right, I quickly introduce this external links mode as well. So what happens here is we are not going to get the results as a payload, but rather we are going to get links to the various chunks that make up the result. That's pre-signed URLs that you can use to actually retrieve the results directly from the cloud storage. And that can become quite useful if you have very large result sets. So inline mode, in our case, works up to 16 megabytes. But if the result is in the order of gigabytes, then you might not want to transfer all of that data over HTTP. So that's where external links can become helpful. What's nice about external links is that you can actually retrieve the results in parallel. So you can actually form URLs to each of the chunks that make up the results, and you can retrieve the results in parallel. So that can become quite useful for large result sets. And then finally, a last detail that I wanted to go over is this topic of SQL injection. I think everybody who's been active in this field for some time knows that if you're sending SQL over the wire, there is a risk that somebody tampers with it. So that's where we've introduced support for parameters. The way it works is basically whenever you have literals, so some input from a user that is used as part of the query, you can actually use placeholders for the actual values as part of the query string, and then pass. So this is the date end, and they start and that date end in this particular example, and use parameters to sort of send those values separately. This means that the values will be interpreted separately from the SQL string, and there is no risk to have the SQL string tampered with and then have some sort of a drop table as part of the SQL string inserted by a malicious actor. So that's also there, and you will see it in action in just a bit from Chris. And actually, yeah, I'll pass it over to Chris to show you how to use all of this for a real app. We will probably use the recordings for part of it.
Yeah, now a good time to mention that this particular API is in public preview. So some of the features we are demoing today, for instance, the parameters, are not yet released even to that public preview. So we're operating on our internal staging environments behind VPN, and that's, I think, the source of our internet activity options if you're seeing Zscaler not connecting. Anyways, so despite that, that's why we have backups and videos. Okay, so there's about 150 of us here in the room today. We're going to band together and build a company called Acme Inc. So we're a company, we've got some stores operating in the US. Each of those stores has a bunch of sales data that we input into our Lakehouse, and we want to be able to visualize that sales data, download it, play with it offline in Excel or something, right? Or actually view live data, insert data into the Lakehouse, right? So this API can kind of do all of that, and we're going to build our own internal API together, right? I want to be able to enable the developers at this company, Acme Inc., to be able to build applications, but not have to understand SQL statements, or if we change data tables underneath that, how to get the list of sales changes, right? Let's just give them an API that says, give me the sales for this store, right? So that's what we're going to do. So sort of our product statement here is we want 3 APIs today that we're going to build. One, give me a list of stores, right? It should return success in an array. Simple. The other one, given a store ID in a RESTful manner of the API request, give me all the sales data for a store. Now, I might have some parameters to this, like a limit, like I don't want all the data, I just want 20 rows to give me a sample, or I might want it in a different format. I might want JSON, I might want CSV. We also have arrow format, so a columnar format that may be more efficient in transit to play with the data. And then last, sort of an insert, right? So I want to add data to my Lakehouse, right? Use a DML query, so it's not just reading. So we're going to set out to build this API together. We're going to look at code. We're going to look at, apparently, a video of how it all works. So let's start with where's my video? That's not it. Oh, we're going to go to Finder here and find the screen recording. Let's hope the latest one is the one I want. Okay, so here I am in my little web app that I've built. It's a Flask app, right? So we're going to hit the home page. And then this is listing the stores, right? So it's small data, right? We only have 100 stores. It's pretty good for 150 employees. But right, there's just not a big list here, right? And so you can see over in my web console, right, the data came back in line. It's just a JSON array of stores, right? So for this version, how does this work under the hood, right? So there's this GET request that we built as a company backed by the Lakehouse, right? That translates into this POST request for the SQL Statement Execution API, right? So it's just a simple select star from stores. In this case, I used the synchronous mode, right? So wait up to 50 seconds. That might be a bit generous for this query, and then cancel it, because I expect it to run in that amount of time, right? There's some SLA, because it's just not a lot of data. So under the hood, how does that actually look like in Python? So here I have a Flask app, so fairly simple. I'm on the wrong area. So in this case, I've actually used the Python SDK that Databricks has. So Databricks is building out SDKs for all of our APIs in various languages, popular languages. I think there was a chart earlier from Reynold about how popular Python is. So I've chosen that, right? So a little bit about this SDK. You can get up and going. All you have to do is import pip install, and then import this workspace client from the SDK, invoke the client, and this handles auth for you, right? In this case, I've actually just used tokens, and I have some environment variables on my machine, but you can also use OAuth, right? And you so invoke this workspace client using OAuth, and then you have access to the Databricks APIs, of which here I'm using the SQL Statement API. So back to this API to list stores, right? To get requests to my backend, I've got a canned SQL statement to list stores. So my users don't need to understand what that SQL is, and we could change it over time. I synchronously wait for the response. And when I get the response, I can just marshal it back into the form that I want for our company's API and send it out to the client. Now, Adriana talked about HTTP and the simplicity of that, right? The Python SDK actually wraps that and makes it even simpler. We're just calling a function with parameters. And so underneath the hood, this is what the Python SDK is doing. It's taking all those parameters, putting them in a class, converting that class to the request body, and then using a Python HTTP client to post it to this URL. I don't even need to remember the URL. I just need to use the SDK and call a function. Right? So that's what we're trying to do is democratize the Lakehouse by making it easy, coming to you in your language, super simple so you can build apps. OK, so that's just getting the list of stores. That's my live demo. Where's my video? OK, so next, if I actually go and I can paginate client side through all my 100 stores, but I actually want to look at a particular store. And so on the landing page for this store, I've got the last 20 sales for that store. So small data again. But now I actually have this download as CSV button, right? So if I know that my data analysts want to go to the site and get a chunk of data, hundreds of megabytes of data to be able to play with locally on their laptop, they can easily do that. So I can give them this button. And this is using the external links that Adriana talked about. Right, so I actually send a request, and I can get into some details here. But you can see in the networking thing here that I'm downloading in parallel from the client, because the server from the Lakehouse actually gave me a bunch of pre-signed URLs. So this external links feature of the API is backed by Cloud Fetch, which is another feature we've built into the Lakehouse. And there was a talk last year at Summit about how that works. But essentially, you leverage the parallelism of Spark to upload the results from your query to cloud storage. In between, on the incremental hops, right, the Databricks control plane server, our Acme Inc., our backend servers, all it does is pass metadata all the way to the client that actually wants to download the data, and it can download it in parallel from cloud storage. And so that gave us sort of a 12x speed up on getting data out of your data lake. Right, so for this bulk download case, that's where this comes in handy. So a bit about that, how that's working under the hood. So in this download case, right, again, we have a GET request. RESTful takes a store ID, and I want it in CSV. And so under the hood, right, we have this canned SQL statement. Select star from stores where store ID equals a parameter store ID. So this is where we'll first see the parameters. And then I've chosen the disposition of external links. And I know this is maybe going to take a long time to run. I'm collecting megabytes of data. So I make it asynchronous. And then my client's going to poll. So I give them back an ID. And then the web browser, in this case, will just poll on that ID, waiting for the query to finish to gather these external links. And so once it does, it's got this list of links, and it can start downloading in parallel. So again, to go back to the Python, that looks like this, right? So when the request initially comes in, I can invoke the Python SDK with a bunch of parameters. I've even thrown in a byte limit because of the Wi-Fi not being able to download more than 50 megabytes, if and when it works. And then on subsequent requests in the same handler, like if there's a request ID, right? I can use that request ID to get the status of the statement to say, is it done, is it done, is it done? And when it is done, I can use the metadata in that request to start downloading or getting all of the pre-signed URLs in a loop. You could do this in parallel or not, but for educational purposes, just a for loop. And then I send that entire batch of pre-signed URLs back to the client, and then the browser will download them in parallel, as you can see in these blue lines from the video. So we've got bulk extraction of data. Now, say we're doing, some store, in San Francisco actually makes a sale. We're finishing the download. We'll keep moving. Download CSV. Yay, there's CSV. Okay, so we've got a sale. I've got some information, some metadata about that sale that I want to input into my Lakehouse. And again, I just sort of can send a post request now to the API we've built. And that will use a DML query to insert it into my Lakehouse. And so that will, right, you can see sort of the parameters that we've got for this payload. It finished. And now when I go back to the sales page for that store, it's not hitting cache data because there's new data. The table changed, and you can see on the first row that our new sale is now insert, and it's live in that particular store. So under the hood, to give you a deep dive there, right, so we're injecting data, right? There's a user form, that's where the SQL injection that Adriana talked about is there, and it's scary. So why is that secure? So I have this insert into command to give you a deeper look here, right? There's this insert, there's a bunch of values I want to put to, and then you have this array of parameters. So we worked with the open source Spark community to build this into the core of Spark, right? So all we send down the stack is the name, a type, so we can do type safety, type checking, and then a value string. So there's no actually manipulation of the SQL, right? Spark will do planning, figure out all the nodes, and be like, this is a literal. I have a promise of some value. Let me go look up that value and inject it in there at that point as a literal, right? So the semicolon drop tables will not work. Spark is not going to see that semicolon, parse that semicolon, and try to execute the other command. Spark has injected this thing into a plan node, and thus is sort of secure by default. Please break it and submit bugs. This is one of the things that's in public preview. So again, under the hood in our Python application, right, I can just build out my parameters, pull them from the REST request that we've built together, and submit them to the function, as an argument parameters. And then the SDK kind of takes care of putting them in the right JSON payload to send to the backend. So that sort of concludes. We've got our app. We've been able to expose data from our Lakehouse into some application to let our sales team see what's going on in their stores. And then we've also been able to add data into our Lakehouse pretty seamlessly with this new SQL Statement Execution API. So in our public preview blog post, we put a bunch of source code out there in a Git repo. The stuff we shared with you today will also be added to there once we go from public preview to general availability and this sort of parameters feature is exposed to more users. And then, so to recap, right, there's this ecosystem of tools to access your Lakehouse, right? Whether it's more traditional tools, BI tools that are going to leverage JDBC, ODBC under the hood to talk to the database, or a connector in your language, Python, node.js, Go, right? So tools like SQL Alchemy, DBT, they're going to use the Python connector. Or now we're kind of leveraging all languages by exposing this REST API, right? We're going to continue to iterate here, and hopefully the community will come together and add connectors and SDKs in various languages that you all love to use. And then again, it's just SQL, right? So it's not, you can do DDL, DML, right? However you want to manipulate data in your Lakehouse, you can do that with this API. And then, we offered 3 different modes, right? So if you have synchronous with the deadline, it's not going to take that long. You can run it, wait for the response, and cancel it, if it's missed that deadline. If it's a big bulk request, it's going to take a long time to run the query. You're doing some complex join, and you want to pull out a lot of data. Asynchronous might be for you. Or, if you're not quite sure, there's the hybrid mode as well. And then again, if you're using large data, you can leverage the power of Cloud Fetch to skip all the hops in the middle and have Spark massively, in parallel, upload massive amounts of data, and then client-side, you can download that. And then again, right, however you authenticate with Databricks for any of your REST APIs will also work for this, and we have sort of SDKs to make that super simple. So these are just some links to go learn about more ways that you can build apps powered by the Lakehouse. And then as you heard yesterday in the demos, in the keynotes, we're building out this apps marketplace, right? So hosted apps on Databricks, right? So you're going to maybe host some of your code and then leverage an API like this to deliver the power of the Lakehouse to your users of the applications. So I think that concludes our talk.